Okay, we are now recording. So, today we are going to discuss the penultimate language or system that we are going to discuss in this class. We are now going to talk about databases. We are going to talk about MySQL and relational databases. So, what is MySQL? MySQL is an open source variant of a group of database, a sort of large collection of different database software which all implement the SQL standard. So SQL stands for Structured Query Language. It is the language that we use to interact with databases. In terms of its similarity to other languages we've discussed so far, it's not it has the ability to be a general purpose programming language, but that's not how we will be using it. Of all of the languages that we've covered so far, this one is the most simple and easy. Particularly if you already have a good handle on writing Boolean expressions. So, if you mess up a statement in SQL, it will fail to execute or compile the same way it will in a more strict language. So we're not exactly in HTML land where you can just kind of go with the flow and it will try to render it how it thinks you want it. You do still need to be rigorous in your statements, but the number of operations which we need to perform is relatively low relative to the other languages we've talked about so far. So, MySQL is open source, free to use, and it is very, very popular on the internet. It's also maintained by Oracle, which are the same people who maintain Java, I believe. Fast, efficient, and functions with standard SQL syntax are taught by almost every introductory database course. So SQL databases, or relational databases, these are your quote-unquote basic model of databases. There are alternative formats, the so-called non-SQL databases, but you can tell that SQL is so important and impactful by the fact that everything else is called non-SQL, right? The major competitor to SQL databases are databases based on JSON objects. This is how things like MongoDB works. Mongo is perhaps the biggest non-SQL database which competes with SQL databases. So, MySQL is used by many large, high-profile web applications, including Google, Facebook, Twitter, YouTube, basically everywhere, right? Your bank uses SQL, your everything from your mom and pop shop, we sell springs of various sizes internet thing where you have to log in. Anywhere you have a login system, there's a good 95% chance there's a SQL database in the back end of it, right? So, MySQL is the M in the LAMP stack, which is what we've been learning in this course. It's included in XAMPP and other local host web server environments, such as WAMP, MAMP, and others. So, long story short, XAMPP has MySQL built into it. You don't have to do anything else to get it. SQL stands for Structured Query Language. SQL allows us to query databases for records, insert records, delete records, and update records. this is generally referred to as your CRUD operations. CRUD, create, read, update, destroy. These are the core functions of most web applications. Although, we are not going to be progressing in this course far beyond CRUD. We're basically going to do CRUD and how to set up a table, right? How to set up a database, how to set up a table, and then these 4 operations. With only those 4 operations, you get a very, very large number of functionalities that you can get out of that. That's all you need to do any password system. Web applications are sometimes referred to as CRUD apps. So many web applications are really just fancy, pretty interfaces to databases. For example, let's take Twitter/X, whatever you want to call it. I guess people are kind of more and more calling it X now, I think, maybe. But anyway, take social media, right? What is your feed? It is a view of a database, right? When you post a tweet / I think they still call them tweets, don't they? Yeah. When you post a tweet on a platform not called Twitter, that information is stored in a database, right? All of the people who are posting things at all times are all being slotted into a database. When you view your feed of that database, you are looking at a view of all tweets filtered for the people you're following. Right? That's kind of the basic functionality if you discount recommendation algorithms, which are in that's a whole different kettle of fish, right? But the basic functionality is, I follow accounts X, Y, and Z. I have the feed of all tweets by all people. I filter that for tweets by X, Y, and Z. That is my feed. Does that make sense? Then you order it by the date, right? You order it by the time at which these things were submitted. Most recent first, and there you have it. That is a social media feed. So let's now dig in a little bit into the structure of a table in a relational database. Fortunately, it's highly similar to the sorts of data processing that you folks hopefully have done so far. How many people have ever used a spreadsheet before? Most of you. Have you not used a spreadsheet? You did? Okay, good. I didn't see your hand. So spreadsheets, take Microsoft Excel, right? Microsoft Excel is basically analogous to an SQL database, right? So you know how in Excel you have tabs along the bottom where you can access different spreadsheets, right? This is analogous in SQL to tables. So an SQL database may have many tables, right? So a database has many tables, right? The Excel file itself is the database. That's the analog of the database. Maybe I'll just write this on the board. That seems like that's a good idea. So, SQL and Excel. So in SQL, we have the concept of the database. In Excel, that is the .xlsx file itself. Databases are also kept in files. They are typically .db files, right? For us, on a web server, the .db file itself is hidden from us. We don't ever really need to interact with it. So, we don't really have to worry about how MySQL is actually storing it in files or, in, different lengths of pretzel sticks all in a row, or, writing numbers on the backs of running sheep or something, anything like that. We don't have to care how the memory model works. We just need to interact with it, right? So, the next layer under the database itself is tables. So the database has many tables. Tables are equivalent to sheets in Excel, right? So far, so good. Within a table, SQL databases have records. Sometimes other terminology is used, but a record corresponds to a row in an SQL database, or sorry, in an Excel spreadsheet, assuming that you've organized your data with the data running horizontally, right? If you've organized your data with your data running vertically, which is totally possible in Excel, then it would be corresponding to columns. The idea with a record is that it is a discrete piece of data stored in a table. So these are examples. If we have a table containing employee numbers, names, ages, departments, and salaries, employee number 3, Rabin R, age 31, department marketing, salary, that number, that is one record. So far, so good? Okay. In addition to, so obviously a table will have many records, right? The other thing that a table contains are fields. Fields typically, fields correspond to columns in a spreadsheet. Fields must have a name and a data type, right? This is different from Excel. In a spreadsheet, you can put any data type you like into a particular cell, right? Could be a number, could be a string, could be a formula, who knows? With SQL, every field has a specific data type. I am not permitted to store anything but an integer inside of the age field, for instance. Does that make sense? So far, so good? So a table will, of course, have many fields as well. Another difference between spreadsheets and SQL databases, in Excel, you can put formulas into the table, right? In SQL, you don't. There's no formula data type. All you're storing is raw data. If you want something calculated from that data, you either calculate it and store the result in the table, or you extract all of the data you need and calculate something from it. Does that make sense? Like, SQL gets more complicated than we're going to cover in this class, but for now, this is a decent level. If you understand it to this degree, then you'll be doing, you can actually do quite a lot with it. So, good. So, Yes. In this diagram, it attributes fields as you have fields of records. So you could say as well that records also have many fields. That's all right as well. So, refresher. You guys haven't, like, you're not taking databases, you haven't done a course on databases yet, right? This is all fresh information? Okay.
We're doing information management right now.
Okay.
Which is like kind of about databases, but like vaguely.
You haven't done any, you haven't like done any of this? You've never seen these before?
Like he briefly went over CRUD,
Okay.
but that's pretty much it.
Okay, well, we're not going to briefly go over it. You will have to do an assignment where you actually have to do some. So, of our CRUD operations, what does CRUD stand for again? Create. R is?
Report.
Report is pretty good. It's read or report, that's fine. U is? Update. D is? Delete. So in SQL, select is read. So when we write a select statement in SQL, we are grabbing what's called a view of the database. We are looking into the database, collecting up all of the entries in it that match whatever criteria we put forward. That gets returned to us. Does that make sense? Hopefully. Insert is pretty self-explanatory. You insert a new entry into the database. Update, again, somewhat self-explanatory, and delete is the most self-explanatory of all. So, I'm going to pause at this point in the lesson, and we'll do some practical demonstration stuff. Did you have a question? No? Okay. So, let me show you how to access the MySQL database that has been packaged with XINF. So, if you don't mind, please open up Mohawk Apps and log in with your valid user credentials. There you go. Within the XAMPP control panel, you will see we have Apache. Apache, remember, our web server. That's our HTTP server. MySQL is our database server. You'll want to start both of them. So, in the same way that XAMPP is essentially emulating the software process of an HTTP Apache server, it is doing the same client, sockets, and Apache and MySQL. So in the same way, stupid firewall thing, in the same way that an HTTP packet is emitted from the client, hits the socket layer, sees it's heading to localhost, bounces back into your machine, hits Apache, Apache generates the response packet, which is then bounced off the socket layer and sent back to the client. In the same way, SQL is picking up packets from the same source. In our case, database packets will be sent from the Apache server. we will eventually be seeing how to write PHP code which sends SQL packets to MySQL. So when the client requests a web resource, it's sending HTTP packets. When the server is requesting database resources, it is actually sending SQL packets. SQL is not only a language, but it's also a packet format, right? So it sends SQL packets. The MySQL database server picks them up, generates a response, which then gets sent back to the web server. The web server then will typically use the data from the database to populate a web page or do something interesting with that data, create the web page, send that back to the client in the form of an HTTP response. So when we add databasing, we are adding a second server. This is important to understand. It's important to understand that the database server is different from the web server. These are two different software processes. They both receive their packets independently of each other. In fact, because our Apache server exists on the same machine as our SQL server, in this case, the Apache server is connecting to localhost to connect to the SQL server. So it's going through localhost the same way that the client goes through localhost to get to the web server. They're both communicating with the same socket layer. Does that make sense? So, this is not necessarily the case. You can imagine if you're talking about a web application that's sufficiently large, right? If you think about something like the Facebook, for example, do you think that Facebook's web server and database server reside on the same physical machine? Nope. Do you think that there is, this is like, the question rephrased is, do you think Facebook is running off of one computer? Right? Probably not. Although, I don't know the internal details. Maybe they have the best computer in the entire world and that's what runs Facebook. And, if there was a power outage, the whole thing goes down. But no, the database server may not be on the same physical machine as the Apache server. At that point, there are sort of two things you can do, right? Either your database server is sort of, they are different machines, but they are in the same building, in which case you would set up a local area network that is not exposed to the internet to hook those two machines together. Or you could do what's increasingly done these days with cloud solutions. Sometimes your database will be server space that you are renting from someone. Google Cloud or Microsoft Azure or AWS or one of the smaller providers. In that case, your database server is off in the cloud somewhere, meaning that your SQL packets must travel through the actual internet to arrive at the server, right? So, in our case, the database will always be on the same machine as the web server. But when you get out there, that may not necessarily be the case. Does that make sense? Any questions about that? It's kind of like, that's kind of like one of the consequences of learning in school. We tend to learn on smaller examples. We don't have the entirety of Facebook to explore, to demonstrate the software. But anyway, so How do you get into MySQL? Well, my friends, MySQL has a little button called Admin, right here, Admin. If you click on that button, it brings you to localhost PHP MyAdmin. This is the web interface for the PHP MyAdmin database. There you have it. So, because this is running on XINF, yes, question?
I've been doesn't come up on my personal computer.
Well, put it down first. Can you open a web browser? Go. Localhost. Then if you so, got it. Good, good, good. So, did you get it? Yeah. Oh, here. There you go. So, quick tour. This side pane is all of the databases that this database server has created. In theory, in the file system, each one of these is a different .db file. These are all for internal use by the server, with the possible exception of test, which might be a hangover from, I'm not sure what. It's empty, so okay. For our purposes, we want to create a new database. In PHP MyAdmin, that is as simple as clicking New. Now, in order to create a database, you must give it a name. So let's call this database My Database, which is, of course, the most creative name. Do not worry that it appears that the language that this database is in is Latin_Swedish. This is actually a character set rather than a language, so just don't worry about it. We won't have to write the whole thing in Swedish. There we go. You will see that that creates my database as a database in our list of databases. So far, so good? Good. Now, we have a database, but we have no tables. It is empty. You can see that, having detected no tables, it brings us to the Create Table dialog. So, let us create a new table. Name, movies. Number of columns, let's make it have, 4 will be fine. Click OK. On this screen, you are deciding what the heading of the table looks like and what the data types are for the things inside the table. So, essentially, we are determining this blue line plus associated data types. There are other options that you can set, but let's just get basic things out of the way first. So, let's say in our movie database we want an ID number, sure, that'll be an integer. Let's see, a movie should have a name. Pretty much all movies have names. Name, so you'll notice that on your basic you don't have a string type. You've got a couple of different data types that look like they might be strings, but essentially varchar, you have to specify how many characters you're allowing in the string, but varchar is like the efficient implementation, I think. So let's say we have a name no more than 32 characters, and that will be the name of the movie. Let's make a genre, which will also be a varchar. There you go. 32. And let's give it a rating. And let's make that a float. Here we go. You can see there are quite a lot of attributes. You don't have to worry about most of them. I'll show you a couple of them as we go along, a couple more, but this is like the basics, right? So, has everybody got that entered in? Good, 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 good. Okay. We then scroll to the bottom and click Save. If we go to the Structure tab, Structure, Movies, you can see that we have an empty table with ID, name, genre, and rating, just like we requested. So, the first thing that we have to do is we have to create an SQL statement to insert data. When we perform operations on the database from PHP, all of our operations will need to be encoded as strings. We are giving the database instructions in a very similar way to how we give programming languages instructions, right? This guy will help you out a bit, though. If you go to the SQL tab, this is a pane where you can enter in SQL commands. You enter the SQL command, you hit execute, it executes it over this database, or this table. Now, it's got a bunch of buttons along the bottom here. These are templates for SQL commands. We want to insert data into the database. If you click the Insert button, you get a template for the insert command. So the syntax is, we state the name of the operation we are performing. In this case, it's insert. Into, also a required word. We have to specify the name of the table that we are inserting into. And then we say which fields in this table we wish to provide values for. The values keyword then tells us, okay, we are modifying these fields. These are the values we're modifying them with. And here, basically value 1, value 2, value 3, etc. These are intended to be replaced with the values that you are entering. So, for example, let's say that movie ID 0 is, somebody give me the name of the movie?
Princess Bride.
Princess Bride. Very good. Genre?
Rom-com?
I was going to say fantasy adventure.
Cult classic?
Fantasy adventure rom-com. There we go. Close enough. Rating?
Harsh.
Well, I actually set it as, it's like a star rating rather than like the
5.
5. There we go. Yeah. I suppose I should have been more. Specific. So, once you have populated all of the values that you wish to enter, you click the Go button, and that executes the statement. Go. There we go. Success! If we go back to Browse, you will see our table now has one record. ID 0, name Princess Bride, genre fantasy adventure rom-com, rating 5. So, shall we do another one? A couple more just for effect. Insert. There we go. Somebody give me another movie name, please. Someone else? Name of a movie? Anybody? You guys watch movies?
Jurassic Park.
Jurassic Park. Very good. Genre? Dinosaurs. Rating? How would you rate Jurassic Park?
4.5.
4.5, you're saying?
Yeah.
I'd say, yeah. All right. Execute. There we go. And you can see Jurassic Park is now in our list. And let's do one more. But this time, I will show you that you can actually leave these fields out to create incomplete records. So let's imagine that rating information is missing for the movie that we are about to enter. So, somebody give me another name for a movie. Divergence. Is it divergent or divergence? Divergent. Genre. Was that like a post-apocalypse thing?
Dystopian future.
Yeah. I'm gonna say Hunger Games, like.
Yeah.
Is that accurate?
It was in that same, like it came out shortly after the Hunger Games, I think, after they made Hunger Games.
You should watch it, it's so good.
Yeah?
That movie, yeah.
Yeah. I don't watch that many movies, to be honest.
The book was good, I didn't watch the movie.
Go! When I was a younger man, I kind of almost, this might be an overstatement, but I kind of like inadvertently ended a friendship by saying that The Hunger Games, I didn't think it was written very well. So, you'll notice, having not provided a rating, it's inserting the default value for that right there. That's how it behaves if you've failed to provide a numeric type. Let's see what happens if you fail to provide a varchar or string type. Let's say genre is missing from this one. We're on 4, I think we're on 4. Someone give me another movie name. Titanic. And rating, how would you rate Titanic?
I would rate it like probably a 5. It's not bad.
If I was going to give it a rating, I would give it the rating too long. We'll give it a 5 though. There we go. So you can see, if we fail to provide